In Lesson 2, we learned about the difference between vectors and scalars. Remember that a vector has magnitude and direction, whereas a scalar only has magnitude that describes it. So we can represent a vector pictorially by the use of an arrow. We can see the magnitude by looking at the length of the arrow. So the length of the arrow tells us the magnitude of the vector. So if you look at vectors v and w, you notice that vector v is a longer arrow than vector w, so that means its magnitude is greater. Its direction is defined as the direction that the arrow is pointing. So they're both pointing in the same direction to the right there. So when we represent a vector pictorially, it has two characteristics. It has a head and a tail. So a head is just the part there, the tip of the arrow, and the tail is just the other end. So we can represent vectors pictorially, but we could also represent them graphically and mathematically. So notice how I put vectors v and w on the coordinate plane. So again, we can see that their magnitudes are different just by looking at their length. Now their direction, all right, they're not just pointing to the right, I have them pointing in different directions. So how do we do that? How do we describe their direction on a coordinate plane? Well, we always describe it with reference to the positive x-axis. So the positive x-axis, right, is in the first quadrant. So if we draw an angle up to vector v from that positive x-axis, then that angle there is how we describe the direction of that vector, okay? And the same thing with the direction of vector w. Okay, maybe we'll call that angle phi. So we saw how we can represent a vector pictorially and graphically. Now let's look at how we can represent it mathematically. So remember, vectors have magnitude and direction, so we can describe the magnitude as an ordered pair. Now you got to be careful with this though, because the magnitude of a vector is not the same thing as its position on a coordinate plane. Okay, so for example, vector v, it just happens to be the same. All right, so if we describe the magnitude of vector v, all right, so vx, vy, we can look over and see, all right, the arrow's pointing, the head of the arrow is pointing to what? 3 on the x-axis, so this ordered pair would be 3, and 4 on the y-axis, so that ordered pair would be 3, 4. So that is its magnitude. All right? So if we look at the magnitude of w, though, its magnitude is not minus 7, 2. All right? That is not its magnitude. All right? Magnitude is not the same thing as its position on the coordinate plane. Magnitude is just the size of the arrow. So when we look at vector w, we see that its tail starts at minus 5 on the x-axis, and its head ends at minus 7. So that's a displacement of 2. So its x-coordinate would be minus 2. All right, and its y-coordinate, so on the y-axis, it starts off at 0 and goes up to 2. So that would also be positive 2. All right, so we can simplify this, though, and we can make it the same if we were to move w over to the origin. So if I just move the arrow over here, right, now its position on the coordinate plane is the same as its magnitude. So you got to be careful with that. Now direction, we describe direction with reference to the x-axis. Unit vectors is another way we can describe vectors mathematically. So we have this little symbol here, we call it the hat, right? And it represents a length of 1, right? So I hat, right, represents a vector of unit 1 in the x direction. So you can see here on the graph that I hat points in the x direction 1 unit. All right, same with j hat. It points in the y direction 1 unit. So for example, if we were to describe vector v as a unit vector, we would say its x-coordinate is 3 I hat, and its y-coordinate is 4 j hat. And the same for vector w. So its x position, remember it's not -7, it's -2 I hat plus 2 j hat.